Hey, this is Mr. Cristando, and I'm going to talk to you about relative error or percent error in this video. So, we've been doing all sorts of measurements in this project and all sorts of approximations. It might be helpful for us to know, just how accurate are our approximations. So, a really good method for measuring accuracy is using the relative error formula. For our purposes, we're going to be finding something called percent error. Alright, so in the last video, we figured out the distance between BSSJ to Maria Hernandez Park. Alright, so kind of going back to the last video, we figured out this distance. Alright, just a really quick recap. What we did is we used what we already knew, which was the BSSJ field. We knew that that was 250 feet. We measured it in centimeters, and then we also measured the distance from BSSJ to the park in centimeters. Okay? When we did that, we found out that the park in centimeters was 23.4 centimeters, and then we used the ratio table and unit value to figure out that BSSJ to the park is 4,178.533. So for our purposes, I'm going to take this and I'm just going to round it to 4,179 feet. Okay, so that's what I'm going to go with for my approximation in this video. So that's 4,179 feet. Okay. Now the actual distance, if you actually wanted to find out what some of these distances were, it's not so easy to Google something like this. So you'd want to use Google Earth. So if you go to Google Earth and you use the measuring tool, right? You could find that just by going to tools up here, or you could use the toolbar up here. You click on that. We could see that if you start at BSSJ right here, and you drag it all the way to the middle of Maria Hernandez Park, which is where most of us ended it, the actual length, according to Google Earth, this satellite projection, is 4,248.97 feet. So now we know what this actual length is. Alright, so now going back to our map here, we know that the actual is, look at that again, we're going to round this, or we could use the ground length, right? So 4,249 feet. Okay, that's what it actually is. So now let's go ahead and figure out, just how accurate were we here? You may have an idea just from looking at it, but, let's use the relative error formula to help us talk about it. So, alright. Here's our formula. Our measured value, alright, let's just start substituting for some of these. Our measured value, again, was 4,179 feet. So we put that in, 4,179 feet, minus the actual value. Alright, so when we went to Google Earth, the actual distance was 4,249 feet. And we put that in absolute value bars because in this context, it doesn't make sense to have a negative percent error, right? So we're always going to keep these positive. That's why we have the absolute value in our formula. And we divide it by the actual value again, which we know is this one, 4,249. Okay? Now, if you want to, you could do this entire computation in your calculator, but, we'll go ahead and we'll just do it step by step right now. So, first, we'll do this subtraction, 4,179 minus 4,249. Press enter. We get negative 70. So we got the absolute value of negative 70 divided by 4,249. Alright, well, this is the absolute value of negative 70. What that is positive 70. Okay, so our absolute value bars go away. Gives us the positive value because negative 70 is 70 units away from 0 on the number line. Alright, and we're dividing this by 4,249. So let's actually do this division now. 70 divided by 4,249. 249. Press enter, and we get this this decimal. I'm gonna go ahead and round this to the not the tenths, not the hundredths, the thousandths place for now. So this is going to be 0.016. Okay. So 0.016. Now you look at this number and it might not tell us so much right now. So what I like to do is I like to convert it to a percent. Now we know that all percents are out of 100. So for example, if you want to convert 20% to a decimal, you know that this is the same thing as 20 out of 100. If you literally do this division, 20 divided by 100, it would give you 0.20. So now if you want to do the opposite thing, if you want to take a decimal and convert it to a percent, rather than dividing by 100, we would do the inverse of that, which would be multiplying by 100. If you do this multiplication, what you're going to get is 1.6%. And then if you want to, I think this is fine, but we can round it to the nearest whole number. So this would round to 2%. Okay, so 2% error here. Now this could really help us talk about it. So what this tells us is that the amount of error in our approximation compared to the actual value was 2%. So we were off by 2%. Another way to think about it is we were 2% wrong in this calculation. Sometimes I like to think about it as, well, how accurate were we? What was our accuracy? Well, you can think about it like this. 100%, that's really accurate, right? If we subtract our error, which was 2%, what we're going to get is 98%. So in our calculation, we were 98% accurate. So that's pretty nice. This is two really good ways to talk about how close we were. We were 98% accurate and correct. We were 2% wrong. So you can think about, like, if you got a 98 on an exam, that's pretty good. That's not bad. Another thing that I really like about I'm not so big on formulas, but this one could be really helpful when doing this. I really like doing this because when you do this first step here, you do the subtraction and you do the absolute value, this actually tells you how much you were actually off by. So we were off by 70 feet, okay? If you think back to the BSSJ field, which was 250 feet, this is actually less than a BSSJ field, So in our context, when we're looking at really big distances, that's not so bad. That's only about 2%, okay? That's not a huge amount of error, okay? So this isn't too bad. That's nice. That tells us that, we made a pretty okay approximation, okay? If you have any questions on this, feel free to ask me during class. And if you do this relative error packet and you analyze your error, please staple it with what you're handing in, and I'll take that for extra credit. Good luck, and make sure you analyze your approximations. It's really important to know how accurate you were. All right.